Hey guys, welcome back. I hope you guys had an opportunity to see the last video where I started showing and explaining how to do some probability problems that came from the Algebra 2 New York State Regents and the AP Statistics examination. I'm going to continue doing that right now. So, consider the probability statement regarding events A and B. So let's get a pen here, A and B. The probability of A or B is 0.3. I'm just going to remind you guys what that formula A or B looks like. It's the probability of A plus the probability of B minus the probability of their intersection. Remember that this intersection can take on one of three values. 0 if it's mutually exclusive, the product of A and B if it's independent, or they will have to tell you their intersection if it's dependent. So it says, here's some stuff, some information right here, and A or B is 0.3, A and B is 0.2, and then this part right here, this given part, do you guys remember what the given formula was? It's P of A given B is going to be P of A and B over P of B. Now that value is equal to 0.8. So we have this guy to be 0.8. We have P of A and B over P of B. So they told you that P of A and B is equal to 0.2 right here. So I'm just going to substitute that for this guy right here. So I have 0.2 over probability of B, and that's equal to 0.8. Now, if you just cross multiply, you get 0.2 is equal to 0.8 times the probability of B, and then if I divide by 0.8, I basically get 2/8 or 1/4, and 1/4, let's get a different color, 1/4 is 0.25. So some of you might say, well, what about this part here? Well, that was some additional information that they gave you. So that was not going to be used here. Remember that this is the conditional probability. Conditional probability typically means that the events are dependent on one another. Okay, let's go on to the next problem. And once again, at any point, please pause the video, try the problem, go back and rewatch it if you need help. So, this was from the Algebra 2 Regents. It was number 34, so it was worth a couple of points. A student is chosen at random from the student body at a given high school. The probability the student selects math as their favorite subject is 1/4. So notice how every time I read something, I just jot it down. The probability that the student chosen is a junior is 116 over 459, so we'll probably need a calculator for this. If the probability that the student selected is a junior or, so if you guys forgot the or, you have to go back to that video. So junior or that the student chooses math. So let's write that down. Junior or math is equal to junior plus the probability of math minus their intersection. Okay? So it says, if the probability that the student selected is a junior or that the student chooses math as their favorite subject is 47 out of 108. So this guy right here is 47 out of 108. What is the exact probability that the student selected is a junior whose favorite subject is math? Okay, so I have some other data right here. I'm going to put 116 over 459 plus 1/4. I'm going to call this guy X. So I'm going to just take out my calculator. I'm going to first make sure that I have parentheses around the 116 divided by the 459, and then I'm going to add that to 1/4. Now, I get this number 0.50272333115. That's not an exact probability. So what I'm going to do is I'm going to hit the math button, then I'm going to press enter for fraction and then enter, and it's going to give me, let's rewrite this. It's going to give me 923 over 1836. Now, I'm just going to subtract this guy right here. So I can either take him and bring him over and subtract it, and then take this guy right here and bring him over and make it a positive x, or I can just bring this guy right here to this side and then divide by a -1. So I'm just going to take 923 over 1836 and subtract it from parentheses 47 divided by 108, and I'm going to hit enter. I get 0.06753, and remember, the question, when it says exact probability, which it typically does, it means you got to leave it as a fraction. So I'm going to go back here, and I'm going to hit the math frac button. So, pardon me, just need a second, I lost it. Minus the 47 divided by 108, math frac enter. And I'm going to get 31 out of 459. So let's go back to a pen. So the probability of both happening, so the selected student is a junior whose favorite subject is math. In other words, who's a junior and their favorite subject is math, is 31 out of 459. So we found their intersection. We found this guy here. There was a part B to this question, and let me get a different highlighter. It's right here. It says, are the events the student is a junior and the student's favorite subject is math independent of each other? Explain. Well, remember, in order to show independence, you have to take the probability of each one separately and multiply them together. If that equals their intersection, which is this guy right here, if that equals their intersection without the minus, if that equals their intersection, that's what we just found, then they are independent. And if it doesn't, then they are not independent. So I'm just going to take 1/4, and I'm going to multiply that by 116 divided by 459. And that is going to give me 0.0631808. But as math frac enter, it gives me 29 out of 459. This guy here gives me 31 out of 459. So they are not independent. So once again, in order to determine if they're independent, you're going to multiply this times this to see if it equals their intersection. I'll stop the video here so you guys can take your time to understand this, and then come back and watch another video where I will do many more examples, because this one took a little while.